my dear VLSI aspirants, welcome to Deep Silicon VLSI YouTube channel. Here again we are taking one more, the good design challenge. Yes, it is a design. In this design, one of the gate is redundant. What is that? We want to find out. That's it guys, that's what the question. We need to identify the gate which is redundant, not required, unnecessarily they have taken. What is that we need to find. Now coming to this guys, for this what is f? If you write down the expression, this is x y bar z, this w bar x z, this w bar y z. Now guys, here if you take this one, it is like x y bar z plus w bar x z plus w bar y z. This is the one. It is in the simplified form, not in the canonical form. So here at this particular instant, if you take like any some variables are like what is that, common and all, instead of struggling here, it's better to convert this into canonical form and you can draw the K-map. Once you draw the K-map, you will understand in the best possible way. Hence, without any delay, we are entering into the K-map. Yes. Now guys, as they said, 4 variable. Okay, of course, 4 logic gates. Like from this it is x, y, z, right? X, y, z, w. Hence we are telling it is a 4 variable K-map. Okay, the 4 variable K-map will be in this way, where we take wx, yz, w bar x bar, w bar x, wx, wx bar. Similarly here, y bar z bar, y bar z, yz, yz bar. Now guys, here you see xy bar means here you take y bar z, here it is y bar z, and coming to the x is mandatory. You can take both w bar and w, hence this will be 1, this will be 1. xy bar z, w bar. Similarly, w bar x, this one. Z means you can take this and this, means these two. Anyway here, so we can keep it as it is. Now the last one, w bar yz. W bar yz. Yz means here. So that here w bar means these two. So that you can take x and x bar, means already it is there. Here you need to take this one guys. So we mapped it. Now here if you simplify, you can take one pair here, you can take one pair here. Now guys, what is this? W bar yz. Similarly this one, x y bar z, this one. Now guys, w bar yz, this term is there. Similarly, x y bar z, this term is there. So what is left over? What is this? W bar x z in a simplified format is not appeared. No need. Hence, this is the redundant term. Okay guys, and from where, from which gate we are getting this redundant term? None other than gate number 2. This one, this is w bar xz is the redundant term. This gate is not necessary. You just remove this, you connect it as it is, so that you will get xy bar z plus w bar yz. This one. So in this way we can identify the redundant gate for any question, for any model. Remember, once you get the finalized expression, you just simplify. Either you take for Boolean algebra or K-map. It's up to you. Mostly it's better to go with K-map. It's a graphical representation. No need to put more efforts. Remember guys. Once you get the simplified expression, now you compare with the original initial expression so that we can easily identify which gate is redundant, which gate is not required. Okay guys, I hope you like the video. See you in the next video. This is Shivram signing off. Jai Hind.